So, I've been lying to you. We've been talking about closures this whole time. So that concept that we've been talking about is the elusive closure that you've heard of. Have you guys heard of a closure before? What is a closure? Yeah, it's when a function is inside of a function that creates
Scope isolation?
Mm-hmm. It's a good way to think of it. Yeah. So a closure happens when you put two functions inside of a function, and you can take advantage of that by returning a function that retains access to its parent function even after it has been executed. So that's a closure. And you've been using them pretty seamlessly so far. So good job. So here's a recipe for a closure. So closures come in different forms, but this is kind of just a guide. So you have a parent function, right? And then you have your inner function. In between your parent function and your child function, you need to make sure that there's some variable there that you can store a value. It could be a variable that you declare, or it could be a parameter value as well. Then inside the inner function, you either want to access or manipulate the function in the parent scope. And then you return that function so that later you can call it and do whatever fun stuff that you want to do. Cool. So that's how you create it. And then there's the execution part. And so the execution part is you want to call the parent function, save it to a variable, because remember it's returning a function that we're going to call later, right? So we need to save it into our variable. This variable is a function, so if I just write out test, it's going to return a function. And then when you call it, it'll execute the function just like we've been doing. It'll return the scope. Any questions? No? Okay. So this is a bit of a gotcha. So when we call this function, so let's see, find someone. It's going to return speak, right? So let's call this someone speak. And we're going to call it. The first thing that we're going to do, right, is we're going to define that function. Nothing is going to be called yet. Who is going to be defined, and then we return speak. What do you think will happen when we do this?
We'll get the function body of speak.
With the who context. Undefined? Yeah.
Well, we haven't called someone speak yet. Okay, so someone speak is now this function. The question is, do we have access to who?
No, because it was defined after the function was declared.
Yeah?
A block scope inside the original function, so it didn't have access across,
Well,
maybe?
so it's technically in the parent scope.
Oh, so let
Yeah.
doesn't automatically create the block unless you use the bracers.
Yeah,
Okay.
exactly. Otherwise, I mean, maybe it would be scoped to the block, which is this parent block.
Okay.
Yeah. Dun dun dun. It worked. Why did it work? So it worked because as we ran through this function, we defined speak, and then we defined our variable. Now this variable exists in this function execution context. And then we return speak, and then later we called it down here. We went back in here, and this who is going to look first in its own context and say, do I have a variable called who? It's going to say no, I don't. And then it will look in the parent context, and it does. So even though it's visibly after that function definition, it's still valid because it has already been defined. And you can tell by the way that it executes. That's why it's really important to understand exactly how the function executes and in what order, because these kind of tricky things can come up, especially when you're like returning functions from functions and all of that. Yeah. Okay. Let's see how many more. Okay, just 2 more. So here's a timer. This is one of the more famous examples of using a closure. Let's run it. All right, so we have our make timer. And we initialize it. So we create elapsed. We create stopwatch, which is a function that just returns elapsed. Yeah? And then we have, we have increase, which increments elapsed. And then we have the set interval. And set interval is just a method that will call the function that's passed to it every 1,000 milliseconds. And you can change this as milliseconds. 1,000 milliseconds is 1 second. So that's why this is like a second timer. And then we're going to return stopwatch. So let's check out what timer looks like. And it's just our little stopwatch function. But we can see how long ago we called that function here. So we called it about 54 seconds ago. And so you can see how you could use a closure to kind of hide away functionality that you don't want people to mess with, right? So for a timer, the consumer of this data should only have access to the time. They shouldn't be able to mess with the incremental, the increase method or anything like that. But you may want to return the interval in case you want to stop it, because it will just go on forever.
Why is it not returning? Since make timer returns stopwatch, which is the function body of stopwatch, then we do timer and parentheses. Why are we not getting back 0?
Yeah.
You know what I mean?
Yeah, it's because all of this shares the same scope. So we only called make timer once. So elapsed has one value in one execution context. And so we return that, great. But we returned it down here. We first ran all of this, which started an interval. And that interval, whether we like it or not, is just going to keep running every second and increase elapsed. So it's going to call this function every second, and it's going to increase that. And so these methods are mutating the value here. This function is only reading it. So it's being changed by these functions. Because if you think about it, they all live in the same execution context. So if one value is changing it, it's going to have access to the same value. Because we make the execution context here for this one as the parent scope. And just because before we didn't do that, doesn't mean that methods can share scope and change the data, and it can affect other things that are relying on that data, which goes back to Michael's point. You have to be careful when you're changing your data because it can affect things. just going to keep going forever.
So what happens if you just run timer without parentheses?
It's just a function definition. But it retains access to its parent scope, and that scope is being retained access by this increase function as well. The increase function still has access and is incrementing it. Even though we're not doing it, you know, it's being done in the back. All right. Here's the same thing with a lot of console logs. They kind of give you a feel. Let me open another tab. So it'll be initialized, and it's going to be elapsed. And then we are going to say timer. We're going to call it, which is going to console log stopwatch.